Yourselves also already exist. But doesn't this also mean that we can't change anything about the future? What do you mean by change?
Unfortunately, we have to dive into this.
If science has taught us one thing, it's that our perception of reality can be extremely misleading. The Earth isn't
That's fully true. So, we're gonna... Yeah.
flat. Solids don't fill space and no one looks like they do on Instagram. That the future is somehow different from the past is another such quirk of human perception that doesn't correspond to reality. At least that's what I think, and today I want to explain why. In a
I mean, go ahead.
the reason is that Einstein's theory of general relativity tells us that the future, present, and past are really all the same thing. They
This is,
belong together to one common entity, space-time, which just is. It doesn't come into being. It's there, has always been there, and will always been there in its entirety. In Einstein's theory, you can't separate the past from the present and the future. It's not logically possible. And this theory is experimentally very well confirmed. This is why I think we can't just discard this consequence. It's like insisting that the Earth is flat because we can't see the curve. Instead,
we can see the curve. That's the problem. There is no way of insisting that the Earth is flat because we can see things like the curve and ships over the horizon, blah blah blah. There are bits of evidence that are irrefutable, things we can be sure of. Move on.
Of denying it because it doesn't agree with our personal experience, we should be trying to understand what it means. This is an argument in 3 steps. The first step is the question of what we mean when we say that something exists. Take the question of whether your feet exist right now. Well, yes, you might say, I can see them, I can wiggle them, they're obviously there. But, says the theoretical physicist, light takes time to travel from your feet to your eyes.
True.
You only ever see your feet as they were a picosecond or so in the past, and the nerve signals from your feet take almost a
And my
second
pizza
to
pocket will be
reach your
microwaved
brain.
in
So
2
you
minutes,
can't
but
possibly
I won't
whether
know
your feet
until later
exist now.
that it has
But
actually happened.
this just
Or the
isn't
microwave
how we
exploded.
think about existence. Most of us are comfortable saying that our feet exist now.
Because one of these are more likely to happen than the other.
And this makes sense because, well, the light and the nerve signals arrive eventually. The fastest of these signals is light. That's the fastest signal possible. Then you can, in retrospective,
If your
deduce your feet existed a picosecond earlier when the light scattered off them that has now reached your eyes. Because it's always been like this, that the light arrived to confirm your feet were there that fraction of a second earlier, it makes sense to say that your feet exist now. The conclusion of this first step is that we speak of the existence of things elsewhere.
Well, the reference to now and the reconciliation of everything in our minds is that perception and whatever else, although definitely skewed by our brains, somehow there is like this simultaneity that happens where we can like touch our foot and the touch seems to happen at the same picosecond. So for now, everything seems to be that everything is now. Even though there's a delay, there is definitely a slight delay. But like, it is noticeably imperceptible from... And you say there's a second between the foot, but I don't believe that because I literally can feel me tapping my foot every time I speak, and that is simultaneous. So, how does that work? Well, it's an illusion made by the brain, possibly. And because of how the brain knows where the hand is, so when the hand goes to do something, then the hand and the brain both and the foot and whatever else all send the signals. They get garbled in the brain until they are all coinciding, so that the same boop is the boop on the other side. So it all coincides into one. It's a really interesting process. But anyhow,
now, even those signals from there have not reached us yet, because we're confident that these signals will reach us later, so we can reconstruct the earlier moment. The second step is done to factor in Einstein's relativity. Einstein's theory spoke.
Physical senses are misleading to the point of not knowing exactly what happened with things, and under like in scientific methods, there are all sorts of things that can be more accurate than your physical senses, like, I don't know, cameras and stuff that have a more sensitive ability to know reality than in exact moments up to a billionth of a second or faster.
Both special and general relativity rest on making time into a dimension similar to space. Of course, time isn't the same as space. It's still different, most importantly, because we can turn around in space, but not in time.
That's a bold statement.
The other important property of Einstein's theories is that the speed of light in vacuum is always the same.
No, I have to stop and go back to the time-space thing because I'm kind of bothered about that, because the whole thing about if you can curve space-time and then you go and make a gravitational situation that is enough that you would have multiple warps of space, and so what you end up with is the ability to have a corridor that has been warped so much by gravity in different ways that it twists on itself and time actually flows backwards. Fun. So, real? No. Definitely not something you're going to find, but something you can create. Theoretically, yes. Reality? No, because that's... My theory is that space-time doesn't curve. However, everyone believes it, and I used to believe it. So I made an entire machine designed specifically to bend space-time. It was the size of the universe, or 2/3 of the seen universe. It was huge, and it was powered by a whole thing and whatever else, and in order to actually bend space-time, it was basically the size of a TARDIS for real, which is gigantic. So the only way that that works is it bends space-time in such a great and strong way, while also keeping itself structured together. You have to be so massive to be able to accomplish this. And I powered it by 4 galaxies of red giant stars. Now, with time dilation as your guide, and the ability to manipulate those stars in the most basic ways to make it so that they would continue to last, they are the most stable. You would be able to have a machine like this be powered indefinitely, and also with time dilation and manipulation of time, you could essentially be able to make it so that all the power that you ever want at any given time would be available to you, depending on how you manipulate space in that object. And so, yeah, things were able to happen that way. I have since moved away from the whole space-time curve and time dilation is a thing. We're going to ignore that entire argument and move on to, what is she talking about?
Physicists like to visualize what goes on in space and time by tossing away 2 dimensions of space so that there's only 1 dimension of space and 1 dimension of time. We then draw time on the vertical and the one remaining dimension of space on the horizontal.
So of course this makes sense that if time just progresses, thinking about it in any number of dimensions is really equivalent. There's not any difference between time and stuff in a three-dimensional manifold, except for that's the whole reason why people think space-time curves, is that there is difference based on gravity and or velocity that will affect how time flows in that area, which she might get to. I don't know. Let's find out.
This is called a space-time diagram, and anyone who moves at a constant velocity makes a straight line.
The idea of someone not moving is, one, impossible in reality. It doesn't happen. You're always moving. So when she says that later on, I'm just going to say it now. Impractical to even think in those terms. But the theory seems to be whatever they say it is.
The angle of the line determines the velocity. By convention, we set the speed of light to be a 45-degree angle. And since we can only move slower than the speed of light, all possible motions are within this region called the light cone.
Well, here's the thing. The idea of the light cone is based on the fact that everything that you could possibly, if you shine a light in whatever direction and whatever else, your ability to do anything about what happened. And in three dimensions, this cone, oddly enough, is more of a cone in the time dimension than it is in the space dimension. But in space, like you can imagine that everything that you could affect out in space, you can only affect that much there, and then other people from different areas of space could affect things a little bit differently.
Motions are within this region called the light cone. This pretty much exhausts my drawing skills. I know it doesn't look very impressive, but making time into a coordinate has a stunning consequence. Is that there is no universal notion of what it means for two events to happen at the same time.
If you want to not calculate things, then yeah.
Because coordinates are arbitrary choices.
No, they're not.
No one is better than the other.
Yes, they are.
And that now holds for time as well. Suppose you
Clearly it wouldn't.
just sit here moving straight up with zero velocity and left and right of you at the same distance.
Let's just say.
There are flashlights going off. If you see them
She said flashlights.
flashing at the same time, you'd say, well, they were at the same distance from me, so they must indeed have flashed at the same time. The issue is that an observer who moves relative to you sees one flash before the other.
So moving more towards the source of light. Yeah, you notice the first one's the one on this side sooner, the other one later. You notice it at different times. This is again about an illusion that happens. Doesn't say anything about reality.
So to them, they didn't happen at the same time. This observer would say instead that.
And again, if you have enough observers that you can correlate all the different bits of information, then you have a consensus about actually when things must have happened. Because they can't all be wrong. Or that is to say that if you compensate for your speed or the speed of the object or whatever else, if you actually do some math for your life, you'll know when things happened. You won't get confused. And other people's perspectives will be compensated and they won't be confused.
These three events happened at the same time. In general relativity, observers who move at different speeds have different notions of simultaneity, and therefore.
They have different observations of events. Because duh. Why do I want to make a fart joke?
Different notions of what they mean by now. You might say, what's the big deal? It's the same thing with, say, sound signals. If you move towards one and away from the other, you'll hear one first, then the other. Yes, but in the case of sound, the relative motion between you and the sound waves changes because the sound travels in a medium, say air. It's got a particular velocity in that medium.
I think what she actually means is that because sound is something that works in cone ways and Doppler effect and whatever else, you can more perceive where and when sound took place because it has a triangulation factor. Light, however, is very straight. It doesn't give a damn to give you its coordinates of where it came from. You just know it was over there at some point. Probably calculatable. But with more observers, you then know exactly.
If you move relative to the medium, the speed of sound changes. So for sound, there's a measurable difference between the two observers. The one moves through the air, the other one doesn't.
One has the Doppler effect of being and the other one has it being
Can then say objective.
It would have been better if I did one tone. Shut up.
The one who doesn't move through air is right about what happens at the same time. But the speed of light doesn't need a medium to travel in, and it doesn't change.
And of course, if you move faster than the speed of sound, then you'll never know when sound happened because you can't have it reach you.
It's the same for all observers. There is therefore no way to tell which observer is right and which one isn't about what.
If you have enough observers from different distances of light, source, and the light goes in a certain direction or whatever else, it also, inverse square law, has the lovely effect of you shine a flashlight on a wall and you move it away, the cone gets bigger. So we can tell the distance of where it started. So we can also do calculations about when it started and other such things if we look at more than one pixel at a time.
Happens at the same time. The only thing you can conclude then is that different observers don't agree on what happens at the same time.
No. They confirm each other's assessments or they compensate for all of the things and then all of the information becomes more certain, not less.
This is the second step of the argument. It's that simultaneity isn't universal. It depends on how you move. And that isn't only odd. If you follow this thought, it entirely erodes our intuitive notion of reality. Because now let's look at step 3. For an observer who sits still, all events that lie on this horizontal line happen at the same time. And by the first step of the argument, we reconstruct what we mean by now from signals that arrive later. So this entire line is what exists now in this moment, and then this is the next moment, and so on. Suppose that this first...
Notice how those outer lines are straighter. Why?
Observer says, if this is now, then everything on this line is also now. And this observer says, if this is now, then this is also now.
Massive grid. All the different entities recording certain signals We got fireflies that can blink with the same moment of time. They know when to. The entire grid knows when to. Their idea of now is so intuned in their head, they are coordinated so that they can blink at the same time sometimes. And fun that happens, although it actually comes out of a random sequence and it only happens the same time, as if like everyone has their own sentence, but they all end their sentence with the same period. Does that make sense?
But they could be an observer at any distance from you, each of whom has their own now. None of those nows is any better than any other. So this means
You're conflating it. Speaking of inflating, what if you inflate a balloon? All sorts of different people simultaneously on different areas will notice the balloon inflating. The speed of light and whatever else sends the signals at different rates, but everyone can see everyone would see it being where it is, and it's inflating. There is no difference in the time on the watch for when, well, in this scenario, because it's all close range. And so it's easy to have a simultaneous now in that scenario. But when you get further and further away, it gets harder. But just means you need to do more math.
every moment, your past, present, or future, is now for someone somewhere.
Observations versus actuality is not the same thing. It's an illusion again.
If you take these 3 steps together, then you arrive at the following conclusion. Once you identify that what exists with a present moment, then Einstein's theory forces you to accept that all moments exist in the same way. This perplexing consequence of Einstein's relativity has been dubbed the block universe by physicists. In this block universe, the past still exists and the future already exists. They are all there in our 4-dimensional space-time, have always been there, and will always be there.
No, because when a light shone from a star billions of years ago, it took its bloody time to get here. However happened with all the other junk that happened on its way here, it still was back then. And for people who are millions of light years in one direction or millions of light years in the other direction can say they receive the information at different times. When they coordinate their information, they would be able to tell you, yeah, it all happened then. And they would know. Because we have ways of knowing. Although I have recently heard that it's actually easy to get this kind of thing even misunderstood, so that we don't actually know how far away or how distant in the past, because also the expanding universe warps all of our ideas of how far things are or have been or were when one was.
In case you think this sounds pretty crazy, it's actually a standard argument that physics professors throw at undergrad students and then just
never listen to feedback about.
The students cope with the consequences. Because how do we make sense of this? What does it mean that the past, present, and future all exist the same way? Yes, I've spent 3 decades trying to...
Okay, the terminology of them existing the same way, past, present, and future existing simultaneous, is again an observer illusion and not how you actually notice reality. So if we take illusions away, if we do proper math, if we have enough people observing, we can correlate the data, know when things properly happened, where it happened,
My head around this. I think that for one thing, it means that our past self still exists the same way as this present self. It's just that our past self.
Observing something of the past is an old signal which is an echo of the past, or a byproduct of the past. Like any light from anywhere is a byproduct of the anywhere, but that doesn't mean the anywhere still exists, although the moment you turn off a light is pretty much obvious immediately for someone nearby. For someone far away, like from the sun turning off, it would take 8 minutes for it to get to here, and then we would start floating away. But also, we would be able to calculate all of that.
Are all disconnected from each other. They can't.
Also, we figured out the speed of light and the distance of Jupiter and the speed, the amount of light discrepancy for being on one side of the planet of the Earth, the rotation, the orbit around the sun versus the other is the time it takes light to get to us from the sun, and then the opposite amount of that, the exact, like, that was a fascinating study.
Communicate, and our future selves also already exist. But doesn't this also mean that we can't change anything about the future? Depends on what you mean by change. The future will be whatever is the consequence of today, but these consequences depend on what you and the matter around you do. This means that the future does depend on what you will do. It depends on what information you take away from this video and how this affects your thoughts and your actions. The opposite is also the case, by the way. The present depends on the future in the same way that the future depends on the present. It's just that we don't think about it this way. Einstein's theories.
Again, observations versus reality. Observations can differ. Reality is okay, here's the problem. First, time dilation doesn't exist. Curved space-time doesn't exist. Everything that happens in any given second happens simultaneously in that second and then no longer happens again. All of the byproducts of a light source or a sound source or the vibration of my that reactions, things, all of this, okay? These things are things that we can say, this happened to that, so it happened to do the thing to the and all of that. And so, don't do this in public. Don't do that to me. It's not a throwback. Shush.
Really are strange, and I don't think we've yet entirely appreciated how strange they are. I explained the blocked universe in more detail in my book Existential Physics, but since I wrote the book, I've come to a different conclusion about the role of quantum physics in this argument. You see, so far, what I told you was all Einsteinian physics, which doesn't know anything about quantum physics. If you take into account quantum physics, the argument becomes more complicated.
This all came from quantum physics.
Because quantum physics has an indeterministic, unpredictable element, which is what happens the moment one makes a measurement. And
this is why we make movies instead of measurements. Single measurements aren't enough. You make multiple, then you know all of the things.
The entire problem of quantum physics is that we don't know just what a measurement is. Now, I used to think that this means it's only after you've made a measurement that the past becomes fixed, so to say, there seems to be a difference between the past and the future in quantum mechanics. But I now think that this unpredictability in quantum physics goes in both directions of time. What I mean is that if you take all the information of a particle that's in the wave function, then you can't predict the outcome of a measurement of, say, the position of a particle. You can only predict the probability of measuring the particle in one place or another.
When it comes to electrons going around an atom, okay, it is an electron going around quadrillion times that atom. And so it's quadrillion times per second. So when you look at it with a fraction of a second, you're still getting millions of echoes. And so, like, if you do 1/1000th of a second, you will get a million echoes. But you might get more. It depends on light persistence division stuff. The speed of the electron is great. And therefore, there is this whole illusion of where it was in the past, because it was there soon enough that it still had an effect on light and everything else, and that's why we see all these different echoes of electrons. But it's going around at quadrillion times per second. We know this because of the diameter of an atom and the speed of the electron in the orbit. 22 quadrillion atomic widths per second. Crazy. And to think in those terms, you'd have to be accurate to the terms of billionth of a second or quadrillionth of a second to reconcile it. And if you're not that accurate, just admit that you're not that accurate and move on.
But that also goes the other way around. Once you've measured the particle, you can't say exactly what the wave function was. You can only say it was more likely to have been this instead of that. And this
because the current natural way that we interact with electrons in order to make a measurement of where they are is doing something that in fact will move it from where it would have been, and therefore we can still know these effects and do calculations to know where it was.
Sort of indeterminism is entirely compatible with the block universe. It's not deterministic, okay, but it still doesn't tell you which moment is now. To put this differently, there's no such thing as a now in the mathematics of quantum physics.
AI would be able to rock your world with how much now they are aware of.
Not unless you actually change something about the maths. This is why I think...
Not the maths. You need to change the ideas and the fundamental functions of the Schrödinger equation and just throw it out the window and actually think of Newtonian. Because the electron just goes around in circles. It has to, because conservation of momentum. That speed around the thing is just going to keep on doing its thing. And because it keeps on changing its orbit in order to avoid itself, it is shifting all the time. And therefore, we end up with these lovely little patterns that we end up with. The electrons, orbitals, are measured, noted, understood, makes sense, comes in packets of complete the diagonal on both sides of the atom are covered, and there isn't like some weird 3 pattern because they can't change that rapidly. You know this because of how fast it is and how fast it deflects. So there's these ideas of what can happen, and how it progresses can also give you a lead as to where the electron is. And if you were to watch it with enough footage, this thing is, in order to get a billionth of a second accurate picture and video, you have to do that with so much bits of information that it's really freaking hard to make all that footage. You have to then sift through all that footage. And It's extremely expensive, but this guy did it with an oscilloscope, which was genius, which gave him the footage of light moving at billion frames per second. It was beautiful.
The block universe is how nature really works, and that our perception of the present moment being somehow special is just false, like the idea that the Earth is.
Listen, the illusions of when things happen, where it happens, can all be just erased if you have enough data points, if you have enough sensors, if you have enough things that can measure all the different bits. Like when you have bullet time, you don't have one camera. You have many cameras that all take their pictures fractions of a second away from each other, so you end up with the whoosh in the matrix. That stuff is happening with an entire line of a chain reaction, a bunch of preordained clicks that all happen to give you the footage in all directions simultaneous and without needing to be in a three-dimensional virtual space. We did that with reality and green screen and smarts. We were able to reconcile when exactly anything happened. Because of all the different pictures, it captured it from all those directions simultaneous with slight degrees of difference so that we end up seeing still motion as he's moving, but barely. All the way around. It's like, zoom! The cameras normally can't do that. That's why we use multiple cameras. And also, the multiple cameras thing makes it so it's really hard to reconcile actual things. But because they're still and not moving, there's no swerviness. There's no blur to it. So you end up with all those different bits. But again, it would be slightly jittery, depending, blah, 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 something.
Flat. Maybe this video, more than anything, explains why I've always been about fit for academia. Because what really is this? Is it philosophy? Is it physics? It's neither here nor there.
Unless you do a lot of measurements and actually do the math. Then it's not philosophy. It's understood. And ridiculous to think of reality being not simultaneous.
Yeah, for me, questions like this are the reason I studied physics, because I want to understand how the universe works.
Me too.
And how about you? Let me know in the comments. That the future already exists can sound a little defeatist, like it doesn't matter.
It doesn't. All of the events that have happened took place and then reach us at whatever rate those interactions can come and reach us. All the events in the future have not taken place yet, although you might reconcile an event happening and then another person reconciles that event happening at different times. Doesn't mean that they didn't happen simultaneously. It just means that you have a different snapshot compared to a different person's snapshot. That doesn't mean anything about reality. It means everything about your and their perspectives. But with enough data points, all things become obvious, clear, irrefutable, and impossible to be wrong about.
Matter what we do anyway, but this would be the wrong message to take away from this video. It matters a lot what decisions you make, whether those were predetermined or not. And since
we're getting into a whole different argument of predeterminism, which again, here's the thing, here's the real kicker. If there is no free will in the universe, that means it's a set of parameters that make everything happen, which means you need to control the parameters. And not doing so is neglect. Know the math, do the measurements, you'll know all the things. And speak with certainty, understanding fully, or allow it to be a question, which is fine. It's okay to say when you don't know something. It's also okay to say when you know something. Be sure you know it.
This is the fresh and new year. I have a suggestion for a simple decision that'll bring more meaning to your life. It's to support Planet Wild, who've been sponsoring this video. I've been working with Planet Wild for more than 2 years now.
Yeah.
If you don't know them, Planet Wild is basically crowdfunding for nature. Every month, their community funds a new nature protection mission, and they document everything on YouTube so you can see what your contribution makes possible. It's why I became a member myself. In their most recent mission, they fought ocean plastic in India. It's become one of my favorites. If you want to start the year doing something that matters, join Planet Wild. Contribute any amount that feels right. And
did we drop a bunch of microbes to eat the plastic, or did we scoop it up with a garbage collector? Backhoe. Duh.
If you're one of the next 100
Did we use blowtorches?
people to sign up using my code
Don't use blowtorches.
Zabina41, I'll cover your first month. All you need to do is scan the code or click the link in the description, and don't worry, you can cancel anytime. If you want to see them in action, watch their mission fighting ocean plastic.
Admirable. So, the simultaneity of now, and all of the things to do with the light cone and the observations, are subjective. They don't say anything about actual reality. There is an actual reality. There is a static now, and it's gone. Now is the now that happened that we then say was now, but it already happened. And the now that is happening is and we don't feel the now, but we notice it later and call it now because it might as well be now, but it's not now. It is what is, and then, or what has been, that we call now. But then, again, there is no future that is noticed. There is the past that is noticed. Talking about the idea that we've had experiments to prove that there is the possibility of a future that can affect the present is ludicrous. Doesn't happen and is irrelevant to actual science. There is no way of making any of that work. And also, there's this whole idea that, like, light and everything is so special, and you definitely can't go faster than it because that would mean going, for some reason, backward in time. And imagine what would happen if you immediately transversed the speed of light by any amount, and let's just say you're walking into moving so fast that you're going backwards in time. What actually is happening? Well, first of all, if you were to start moving back so fast that you end up starting to move backward in time, the instant that you start moving backward in time, you would collide with yourself and explode. That's kind of sucky. It happens to everyone who makes a time machine and just sits there expecting time to warp around them. Because guess what? Your past self was part of that stuff that you're trying to warp around. Instead, moving through time is a lot safer if you have a corridor that you warp space enough that allows you to go through time forwards that ends up in the past backwards. And I really got stuck on the inertia concept, but then there is no actual inertia thing. I was stuck on that for a bit, but an actual time tunnel, like I said in a previous video called Time Tunnel, I talked about the whole idea of approaching the time tunnel from the side, and who cares about that? Because when you're going into the time tunnel, you're just going to end up having some part of you immediately start going towards the past, while the rest of you hasn't fully gone into the tunnel. This happens with abrupt edges. Don't do it, you'll spaghettify. However, if you go in through the front, the opening, then you go in, it transitions normally, and you just go through time at whatever rate and possibly experience acceleration depending on how fast the time per time is moving backward in time compared to forward time. But at a big enough scale and at a large enough system, you can go backwards in time, go backwards fast, and end up not just a second per second, but also any amount of time in reverse without experiencing the weird effect of acceleration, because your relative motion through the space hasn't changed, but your motion through time has. And for some reason, because of the warping of space, the tunnel that you've made allows for an accelerative area and a decelerative area, which is gradual. And that's the only way that you can make time machines ever work, to go backwards in time. Also, they only go backwards in time up to the point of the creation of the device itself, meaning you can't just progress yourself past into dinosaur times, because that temporal passage doesn't exist then. It was made when you made it, and it won't happen otherwise. There is another idea, however, that all moments becoming simultaneous stop existing and are only a progression into the future. So everything that you have existing now is the only now that there is. Like Mario in his current frame, he can't go backwards, but he can move forward on the frame, but he could stay in that box for a while. And that would be weird and stuff. And the idea of going backwards would require remaking the universe in an older, different causal relationship. That if let's pretend that you tried going backwards in time a nanosecond, and there literally is only the present. You go backwards a nanosecond, you exit reality entirely. You end up in an empty void of nothing. And then everything from then on is you in a void progressing forward. There is no other time. There's no other stuff. You're the one that existed back then. You're the one progressing that timeline. You can't grandfather paradox yourself in this scenario because you don't exist any other moment other than the then that is progressing into the then future. This is not a theory I have ever heard before. It's not the first time I've talked about it. But it's weird to think that if you simply just have this moment that is only now and progressing into the future because of interactions, literally any moment in the past did not exist. It is the now that is being overridden by interactions leading into the future. There is no past. Can you warp yourself into the future? Could you jump forward into a moment that hasn't existed for everyone else? And equally, no. In that scenario, the future hasn't been rendered yet. So therefore, if you try going a nanosecond into the future, you literally exist only there. Another timeline, just you moving forward. Will the past then catch up with you? And the answer is no. Why? Good question. Would the past catch up with you? Imagine the idea of someone not moving through space, right? Well, they're using all of their motion to move through time. Simply not moving at all, like a Bose-Einstein condensate, apparently is it moving to the future at the fastest rate. Well, that doesn't work. The Bose-Einstein condensate has a time of how long it will last in its current state, and it will eventually restart, and begin to wiggle and do its electron thing. It won't stay cold forever because the elastic properties, the electromagnetic properties, it will just dissipate, spreading out into its individual parts. Which means if you were to have a gallon of Bose-Einstein condensate, first of all, how the fuck did you make a gallon of Bose-Einstein condensate? The center of it can't be affected as much as the outer edges, and therefore you wouldn't just have a Bose-Einstein condensate gallon. It doesn't work that way. But that's another story. So, okay, we've talked about the idea that if curvature of space-time does work, and you could super hypercurve it enough that you basically do a whole what the hell was it? Klein bottle, or the other word for the band that you twist and it does a thing. Why am I thinking of Klein bottle before I think of Mobius strip? Whatever. You Mobius strip the time frame, and then time then flows equally backwards as it does forward. This does work. The geometry of all of that works as long as you can bend space-time enough. And that allows you to, again, move backward enough in time to the point of the creation of the device. Does it also allow you to move from that past forward? The answer is it must, technically. But then, here's a different scenario of time manipulation. What if you have an object that is able to change the very fabric of reality itself, such that some weird pulse or whatever else is warping space enough, or something, that you're able to progress backwards, independent of there being a machine and everything? It is the machine moving through space now, and all of space. And so all of what happens is you progress backwards while everything else is moving forward. The problem obviously still happens that if you encounter anything, you're going to have some weird spaghettification nonsense because of the difference in velocities. People think, oh, well, if spaghettification happens with time warping, then would a black hole be spaghettificating because it is a time-manipulated object. And the answer to that is skeptical or speculative at best. So, all of that stuff. But if you could progress forward through space, still going backwards in time, as an independent object, somehow, it is possible that you could go easily faster than light, but you wouldn't have to move relative to anything, except for you still have to avoid bumping into yourself. So you have to project yourself in a way that changes everything around you instead of allowing yourself to maybe interact with your it's a whole mess. Just you traveling is like, yeah, you're going to end up going backwards in time, but not causally backward in your own time frame. Causally backward into other time frames. So, like the supposed tachyon, it supposedly moves forward, but its actual start or existence being was initiated in the future, and the forward motion is witnessed, but is actually the tachyon progressing itself backward. These don't exist. But if they did, that'd be kind of fun, and a machine doing something similar to that. Please understand, I've already made a ship theory of how to go faster than light. It's called a vortex engine. Naturally, of course, you're going to have to compensate for torque, so you're going to have two vortex engines, and then the best scenario, probably four. The main thing is that all of space that you're moving through is not just pushed behind you, but you're pulling towards what's coming towards you. The faster you go, the more you can have to interact with, and the faster you can go. This is impossible to be anything other than infinitely acceleratable. There's no reason to think that you're going to need more power. The reason why in a LHC, Large Hadron Collider, or magnetic field coil tube, the reason why they can't go faster than the speed of light is because they're doing only pushing on an object. If the object was pulling itself through, then everything that it interacts with is another thing that gives it more speed, and the more pulling and the faster you can pull and the faster you can move forward, then the faster you will interact with things that you can then pull on to allow you to move faster. It literally is a runaway train that's going to just zoop you forward in space. As long as you're able to keep on adding enough motion through your device, the pulling action is very different than any pushing action of an LHC. Push is literally limited. You can't push with any more effort than what is being used to push with. So if that thing can't be accelerated itself to faster than the speed of light, although it gets up to 99.99999 the speed of light, you realize all you have to do instead of push is pull, and you can vastly go past the speed of light. No problem. But that's the thing. Limited minds think about just pushing and think that's the only way you can go forward. And I'm like, why? All you have to do in a set of teeth is pull yourself up the teeth and the screw will move forward. The faster it screws, the faster it pulls up the teeth. And the teeth moving forward or moving towards it can make it an illusion that it's actually, but if the teeth are just stationary, or if you're moving along with the thing that is the teeth, so like a laser beam being pushed behind you, like, again, the beam is only able to go the speed of light. So in order to travel along it and pull yourself along a laser beam, it would have had to have already traversed the distance, and then if you can pull yourself up the laser beam, then you can only travel as far and as fast as you want to up to the distance light has already taken that travel. But who cares about laser beams? You already have light that has gone from the sun, has persisted for millions of years, out in whatever direction, travel up that, and you can travel as fast as you want. Or simply travel towards any other beam of light that's coming towards you. Because it's already there. Just pull on it. Boom. You immediately end up at the source of that light. Immediately? No. That was an exaggeration and a joke. You caught me? Good. You're paying attention. It doesn't work immediately. Nothing does. But it is way more likely that you can then pull yourself towards that source of light. And even though it has taken its time to move forward, that beam is still coming at you. Even if the source is moving away, that beam is still there to interact with, to pull yourself along with. So you can do a lot with that, but people are so forced on rockets ideas, they can't think of pulling. It just doesn't work. Pulling is so weird, except for an octopus, who can only pull. Pushing feels weird for an octopus. So that's why they made a piano where the octopus has to pull a thing to make the sounds. And then it does. And it learned how to piano. Because pull is more makes sense to octopus brain. So if your rocket do pushy, you're limiting yourself. If you pull more, less limited. Right? And that's why the car is able to move faster than the wind. It's pulling on the wind that's moving towards it. So the faster it's able to, harder it's able to pull on the wind, just like any plane, you're able to move through. This is why you move downwind, not upwind, as you're trying to get your plane to take off. Because then you have more wind that you can pull on. More stuff to interact with. If you move upwind, all of the wind that you're trying to pull backward is moving away from you. Less to do stuff with. Less density. You know? Does that make sense? So moving towards a beam of light from a pulsar from long distant away, billions of years ago, that's still pulsing, by the way, and is now an extra distance away, gives you more chance to go that far as fast as you dare push your engines. That's what a pulling vortex engine does. But it's really hard to make a proper pulling vortex engine work without like stress on all the parts and everything. But electromagnetic pulling vortex engine, less stress. And then all it is energy that is flowing, moving, rotating, doing its stuff instead of matter. And at that point, you're able to then pull yourself forward. Imagine if the LHC was trying to drag itself along through space instead of push objects through space. The LHC would be so powerful as an engine. But we don't think in those terms. We think of pushing. Pushing and guidance and friction with all the other stuff. Making sure everything is cold enough. Making sure the vacuum is vacuum and not open area space. But if you have actually more stuff to interact with, less vacuum, you actually have more to pull on. So you have more ability to move yourself with more momentum of stuff to then push back on you. And it's not just the push back that gives you the energy, it's the pulling it towards you thing that then gives you the energy to do things. Negative pressure. Which people say, oh, we need negative mass. No, you need negative pressure. You can make negative pressure with momentum. You don't need, like, vacuums already understand negative pressure. Why do you think it's so weird and hard to make something with supposed negative mass? Just be vacuum. You'll be there already. It's so faster. It's so simple. Right? But then not just pulling stuff through yourself, but pulling stuff through yourself and then allowing it to add on to your mass, be more stuff that you can pull through yourself. The heavier you get, the more mass you can pull backwards, but also swirl back up slowly so that you can continue to move at a fast rate through space and then shove it all back down while all the mass goes back up slowly, much slower than it ever does going backward. And so you can continue your fast motion through space. That's how a vortex engine works. And you can also make it so that the outside motion and stuff also does pulling. And so all of the inside and outside does pulling, and all of the interior does all of the pushing it up again slowly, leading up to the top so it can pull again back down just as hard. It's a whole thing. The guy who made the microwave engine, I mean, you're talking about very tiny amounts of energy that you're trying to make with microwaves. Just make sure that you buffer the stuff, make a sponge or whatever, and whatever, I don't know. We're talking about rockets and stuff at this point, and stuff that failed because he didn't know what he was talking about, and people judged him too harshly, not realizing you need a different angle than 45 degrees to make that work. It has to be as shallow a degrees as you can make it. 45 degrees actually eats your energy because it's more likely that it's going to have sideways is going to then all the motion of everything moving towards is going to then push more directly. And so you get more of a backwards. But if you gradually do it, then it doesn't have the ability to convert its power towards backward as much as it does forward. It does more sideways because it's gradual. It can't do anything other than be gradual and sideways once it gets to that side. And therefore, all energies would only push majoritively in a large amount forward. He was right about that engine idea. He just didn't have the right geometry. Freaking 45-degree angles was too simple-minded. I don't understand why he did that. But, I mean, it's unfortunate because that microwave engine would have totally worked if people had the proper ideas. But then again, people ended up making the goddamn mirror array, shooting the laser beam of the light from the sun up into a tower to heat a tube of molten salts in the tower, instead of taking that beam that was concentrated, pushing it back down towards a pool of molten shit, and then you don't have to bring the stuff up in a tube. It's in a tube. It's in a freaking pool. That would have been smart, but instead we ended up with lava. And oh, it can't work in lava state because that's too hot. Because you're too simple. You can work far beyond lava. With the power of the sun and it being sent towards a pool of stuff, then you can diversify all the light. Also, you don't have to send the light through the air. That's a big waste. Concentrate it. Send it down through tubes. Translate it with lenses. You don't have to heat up light in anywhere other than the area of these little boxes that have the reflective ability, and all concentrating towards where it's going to then be bounced down towards and concentrated, lensed properly. So that you could take that laser light and then send it through tubes to wherever you want it to be, in any direction you want it to be, and concentration that you want it to be. And it doesn't have to travel through the air, burning chickens and whatever else as they fly through it. Because chickens are more, you don't mind hearing about chickens. But if you hear about any other birds, it's like, oh, that's sad. Stop it. Stop wasting billions of dollars on text ideas that could have been, if I was in charge of those ideas, would have never wasted all of that money. We would have had the solar stuff working correctly, and it would, like, not even hindsight 2020, just conceptual art and everything else. What's all that heat going to do to the air? It's going to suck. Oh, great. Let's not do that. Freaking convex mirror as a goddamn side of a building, lasering everything, including the birds. We already know about this phenomenon. Why did we do it as a power structure? It doesn't make sense. I'm off topic. I don't care. Time, light, energy, focusing stuff, the ability to move forward, the ability to concentrate the energy of something else and then have it do things more than what it normally does. I mean, if you have solar cells, you can already move fast because of everything else moving towards your back end. But if you're pulling yourself forward, you can do whatever you want with whatever light that you get. But you have to reverse the motion of it moving towards you. Use that as a way to move forward. And how does that work? Easy. If the light is like a ribbon and you have two rollers, the rollers are going to move up the ribbon, right? So just make rollers to move up the ribbon. Vortex engine. You're done. That's just moving through space. Let's talk about time more. I don't want to. Time is very weird. But the perception of time, again, does not mean simultaneity is not simultaneous. It just means your perspective needs calculating. Do the math. Have enough perspectives. Have a long enough perspective that it's not just from one moment and that's all the information you have. This is why we have multiple sensors, multiple things that can do stuff, compensation for your own effect on the thing, and knowing that, you can know where it would have been. You're influencing where it will be, but you know where it would have been. you know where it has been. You know where it would have been. You don't have these weird numbers that are false and illusion because you have figured it out. Like we know how to make and repeat the way of making ice crystals to the point of making an exact snowflake perfectly multiple times in a laboratory. Some guy just does this. There are things we can just know, and there's no reason to think that, well, we can hope that it does all the things. No, we can control all the different aspects to the point where we can recreate snowflakes. Why do you think it's so hard to figure out where the electron is going, where it's been, and all of that stuff? We can figure it out. We can know these things. Me, without doing any examples of explanations of experiments, I can still look at all that stuff and say, yeah, we can know all this stuff. Boom, boom.